Okay, hi everyone. Um, so this is the session 9. Yesterday we were supposed to have a session, but I'm not sure how it worked out. We didn't have a Q&A session, but now this is the lecture portion of the class for Tuesday. Okay, so let me just lay out everything that's happening right now. So we have some homeworks and a project due supposedly last week, but we didn't really work on that. So we're gonna push it back to end of this week. So everything up till session 8, homework, projects, and everything, you can send it to me by end of this week. So as far as homeworks are concerned, some of you have um, submitted your homework, and I was grading them, and I wanted to explain some of the stuff that you commented on. So I actually uploaded a video for um, some of the questions that I wanted to address. So if you want to do that, if you want to go over, or if you want to see what other people did, you can just go on to the YouTube channel and you'll see some stuff there. So far, I uploaded 2 extra videos, so you can just refer back to them. So if you have any homework, or if you have any assignments done, just send it over to me via email so I can see it. I can make a comment on it, or even make a video for it, right? And some of you have asked for textbooks, but I think we already established this before. But for those who weren't here when we had the discussion, I I cannot give you the file for a textbook because it's against the law to do so. I did not get an approval from the publisher, so it's against the law to give you guys the I mean the PDF file for the textbook. So, but there are a lot of resources on statistics because this is only an introduction class. So I email some of you some resources. So these are the 2 websites that I found, and this is the online textbook, which is totally free and free of access, free of charge. So here they have content, introduction to statistics, describing univariate data, describing bivariate data, and so on and so forth, right? So you can just click on these, and they give you content, so descriptive statistics, and it gives you some explanation, and we discuss like box plot, right? Something like box plot. If you click on it, this is how they describe it. So if you want to look through that, please go ahead and do so, and I am more than happy to give you these kind of resources, but I cannot give you the textbook, just to be clear. Right? So, and they have some exercises as well, so you could do that as well. And this is another website that I found. It's same thing, online textbook. So you can actually download the version in PDF, or you can just go through these and look through it. So water statistics, importance of, and these are some of the things that we discussed so far. So you can do that. All right. So those are the resources that you can use. And today, actually, we're going to do an exercise. It's very similar to the project that I assigned you. So if you follow along with it, I think you will be able to do the homework by I mean the project by yourself. So just bear with me, and starting tomorrow we're gonna start a new chapter on probability. And probability is a very different chapter. It's not related at all with the stuff that we discussed so far. So it doesn't have anything like correlation, or what do we linear regression, any of the stuff. Like, we're going to do something similar to mean, but that's as far as close as it gets. So it's a totally different chapter, and we're gonna take it very slow. So meanwhile, you can catch up with all the rest of this lecture if you're a little behind. So that's why we're jumping on to another completely different chapter, and it's going to make sense afterwards once we do it. Yes, so that's that. All right, so let's move on to the class activity. All right, and as I mentioned before, this is very, very similar to the project that we have. So please try this, and I assume that you will be watching this video at home, and you will work on a work this have a discussion in class. So what I recommend that you should do is that um, so for this particular class activity, we're going to look at the relationship between exam 1, so this column, and exam 1 and the final exam. So these two columns we're going to focus on. Alright? And you can use the same exact questions in class. You guys can do exam 2 and final, or exam 2 and 3. Right? So these are the four variables that we have, and we're only looking at two of the relationships between the out of the four. So what you can do is you can look at the relationship between exam 2 and final, or exam 3 and final, whatever you like. You can do that in class as a group. Okay, so please do that, and let's just get started. All right, um, so first question is draw a scatter plot compare. Okay, so before we do any of that, let me just explain what the set of data represent. The first exam, second exam, third exam, and the final exam, right? So it gives, I'm not sure how many there are, but I believe it's 20, okay, 25. So these are the scores of 25 students, and there are 4 exams in total. First exam, second, third, and the final exam. And we're trying to see if there is any correlation between these variables. Okay? So that's clear that these are the exam scores, and that's pretty straightforward. And jumping on to the first question, right? So it says draw a scatter plot comparing the first exam score to the final exam score. Okay? So we are going to draw a scatter plot. And what does the relationship appear to be? Right? So what we're going to do is we're going to make a scatter plot. And we did that. So we go to insert, right? And we go to scatter plot. Oops. This is not, it doesn't look right. I have to select the data first. Okay, let me just start over then. Alright. So we can choose these columns, and you can press Control to select another one. Okay, so these are the data that we're using, and we're going to go to Insert, Scatter Plot, and here it is. Okay, so we can change the title to Exam 1 versus Final instead of just Final. Right? And if we okay, so let me just make it a little smaller. Okay, so here it is. And if you were to label these axes, we can do axis title. Here, this is the exam 1 score. So this is exam 1. And this will be the final score. Okay? And we see a pretty clear correlation going on, right? So if you were to draw a trend line here, right? If add and then go to trend line, and we can choose linear, and we can choose to display the equation, right? So display equation on chart. Click that and then close. Right? So here is the equation. So we see a positive correlation. So you would write it down. You would say that, okay, so, oops. So you can see that from the scatter plot, it seems clear that there is a positive linear relationship between the first exam score and the final exam score. Okay, so that's it for number one. So moving on to number two, what is the correlation between the first exam score and the final exam score? Okay, so now we're looking at correlation, and to find correlation, we're going to use the data analysis tool pack. Okay, so if you haven't downloaded it, you can go to File and then go to Option, go to Add-ins, and then you can manage the add-ins, right? So go to Manage, and then you can click off the Analysis tool pack. And then you press OK, and then you will have this thing, Data Analysis, in the Data tab. Okay, so that's how you install it. Alright, so let's do that. Data analysis, and then we're looking for correlation. So we go to regression, right? Because this is what we're doing. This is the linear regression portion. So press OK, and then you can select the input range. And for Y, we're doing final exam score, right? So that's the quote unquote the result. So you can choose Y range, and then for X range, you can also choose the first exam score, because that's on here, right? That's on the x-axis. That's what we want. So from here all the way down, okay? And yeah, why don't we just do labels? And we're going to have the result in a new worksheet, okay? And we want to see the residuals and residual plots. Okay, press OK. And this is another tab that we have, and we can just name this summary. Okay. Okay, we can do regression summary. The first sheet, this can be the data. Okay, so let's look at the regression summary. Alright, so we have multiple R. What is this? Again, this is the correlation coefficient. Okay, what is R squared? R squared, we call it coefficient of determination. And what this means, oh, let me make this bigger again. Right? Coefficient of determination, it means how much of the variation in Y is explained by the model or the linear regression. Okay, so how much of the stuff, how much of the observations are kind of covered by the model? Or by model, we mean in this case the linear regression, the line. Okay, so the higher the value of R squared, the better it is. So we can say that here it's about 0.9 0.89, sorry. So we can say that 89% of the variation in y meaning final score, right? That's how we labeled it. Let me just write it down here. X equals first exam score, y equals final exam score. Exam score, right? So X is first and Y is final. So pretty much what we're saying here is that 90, oh, I keep saying 90, sorry. This is 89% of the variation in the final exam score is explained by the regression. Okay, so this is how you would analyze this, how you would view this. An observation, number of observation is n. Standard error, it's kind of like standard deviation, but we're looking at the error. So difference between the observation and the model's prediction. Okay, standard error. So this is where you see to check the model if it's significant or not. And the higher the value is, no, let me say this. The lower the standard error, the better it is. So that means that it explains and it catches the observations very close as possible to the model, to the linear regression. Okay, and number of observations is 24. That's equal to n. Alright, so we're not looking at this, but let's see. Oh yeah, residuals are here, and also we look at, I don't know why it's 73, but yeah. So residual plot, you have to analyze if there is any pattern going on. We theoretically we want to see a random residual plot. Okay, so here if you're looking at this looks pretty random, but these two are pretty out far. But just looking at this, it looks pretty random to me. So I would say this is a good residual plot. I mean, there is an empty space here, but the observation only starts if you look at the data here. If you look at it, there is not really not much going on. Like for example, we don't have a 0 score. I think the minimum value we have is here it's 53, so that's the lowest it gets. So this, I would say this is a pretty random residual plot, except that there is a gap here. So it's not like spread it apart across. Okay, so that's the residual plot. Going back to the question. Okay, so this is asking the correlation between the first exam and the final exam, and that's right here. This is a correlation coefficient. So you can write that down, or you can just copy and okay. So this is the correlation. And again, as we mentioned, there is a clear positive a pattern, linear pattern, and we see that this is explained because the R is almost very close to 1. And 1, when it equals 1, that's the perfect positive linear relationship. So, I mean, we don't have the perfect linear relationship, but we do have a pretty high number for correlation. Okay, so find the regression line for predicting the first exam score and the final exam score, and that's given right here, right? So this is a linear equation. We can simply copy this and bring it down here. Okay, so this is the equation that we're using. And x again equals the first exam score, and y corresponds to the final exam score. Alright, so if someone had a 45 on the first exam, what's the best estimate? Oh, okay. Let's do number 4 first. So if someone had 100 on the first exam, what is the best estimate of his or her final score? And here we use this formula again. Because what it's essentially saying is, what is the value of y when x equals 100? Okay? So what is the value of y when x equals 100? Okay, y equals question mark. And we just simply use this. So equals 1.8525 times 100 plus 15.622. Right? If you press enter, this is the estimate of the final score when the first exam was 100. Right? And same thing here. If someone had a 45 on the first exam, what is the best estimate of his or her final score? And you would do the same. Equals 1.8525 times 45. Right? In this case, the first exam score was 45 plus 15.622. Press enter, and this is the best estimate of the person's final score. Right here, now it's asking for the mean of the first exam score, right? So for mean, we always use, what do we use? We use average. And then we give it a range. So this is a range for first exam. Press enter. And this is the mean of the first exam score. Okay? And it's asking for the standard deviation of the first score. For standard deviation, okay? Some of you were a little confused about this concept, but when we were doing it manually, we would have to divide it by n minus 1. But here, if you're using the standard deviation function, you don't have to do any of that, right? So you can just do STDEV dot. I'll always use sample because this is a sample. We never have, theoretically, we do have a population sample. Population deviation. But practically speaking, we're never gonna have the whole population data. It's just very, very hard to get, right? So we always use standard deviation dot s, and that's for sample variance. Standard deviation. So just do that. Use the function and select the range. I selected the wrong range, so let's go up and fix this. The way down, and this is the standard deviation of the first exam score. Okay. Well, that's pretty much it for the questions that we have. But let's just do another thing here. Let's do a five number summary report for this set of data. Okay, so I'm just going to copy over the first exam because that's all we're gonna use, and make another tab. Okay, we're going to do a 5-number report. So first is minimum. Okay, we have Q1, median, Q3, and maximum. Okay, so here again, minimum is always min, and then range. Right? This is a good review for us because we always did this. Quartile dot exe, and then choose a range dot first, because we're looking for the first quartile. Okay, and press enter. Median, it already has a function, so just do median and select range. Q3 is quartile. Okay, sorry. Equals quartile .exe, and then you choose arrange. Oops. And what? We have to choose 3 because we're looking for the third quartile. And maximum is always the same. Okay, so these are the 5 numbers summary report. Okay, and let's just do some exercise. We're looking for percentiles. Okay, let's do 90th percentile, 85th. Let's do 40th, 15th percentile. Okay, and how do we do percentiles again? Equal, we have percentile, right? .exe again, open parentheses. You give it the range, choose the range, and here if it's 90th percentile, it will be 0.9 because this is always out of 100. And 90th percentile is 94.2, and that kind of makes sense because the maximum score we have is 96, and that falls right in the range. And do the same thing for 85th percentile .exe, open parentheses, select the range, comma, and here this is 0.85 because again this is out of 100, and 85th percentile is 93. Okay, and you would do the same thing for 40th, comma, 0.4 because this is 40th, and that's 78. And let's look for lastly 15th tile.exe, and then you would choose a range, comma, 0.15. Okay, so these are the percentiles that we came up with. And why don't we just draw a box plot? Okay, box plot again graphically represents the 5 number summary. Okay, so let's just draw a box plot based on the 5 number summary we have, right? So box plot. So minimum, okay, so we have to draw the number line. Say this is 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay? So minimum is 47. So 47 lies approximately here, so you would draw the first line. And maximum is 96, so maximum is right here. And we have to draw the box for interquartile range. Again, interquartile range, also known as IQR, is the difference between Q3 and Q1. Right? So Q3 is 88.5. 88.5 is approximately here. And Q1 is 71.5. 71.5 is around here. Okay, so you're gonna make a box for IQR, and then in the middle you draw a line for median. 79 is approximately here. Okay, and then you connect the rest. This is the box plot. Okay, so what can we say about this graph? All right, so let's briefly talk about this again. So since this is a middle number, from here to minimum, this part, that's a first 50%, correct? Because median is half, like it's the half point. So if you go from here to here, that will be the first half, and here is the second half, right? So what if it's like that? We see the skewness. Like if you were to draw it out, kinda, it would look something like. I'm trying to choose another color, but this is not helping me. So it would be something like this. This is skewed, right? Skewed to the left. Because the distance between the median and the minimum is longer, much longer than this, right? This is skew to the left. And if something, when something is skewed, we said the median is a better measure of the center. Okay, so if you were to look at the average of this, so why don't we just look at the average? Okay, it's taking some time. Um, okay, so I mean we did find the mean before, but we can just do it again. Mean, so average, and then you select the range here and enter 79.04. So 79.04 something's okay, so I think there was a 79 should be around here. Okay, so I think this is out of scale. That's why. Actually, if you look at the median and the mean, they're almost the same. Almost, approximately the same. And what does that represent? I'm sorry this happened because this was out of scale. But that represents that it's not really skewed to the left. But this is symmetrical. And we talked about this when we were talking about the shape. Okay? So when we are describing, when we're talking about descriptive statistics, we first talk about the center, spread, and the shape. Center is noted by either median, okay, so mean or median. This is represented by variance or standard deviation. And this is simply the shape, description of the shape. And shape is when it's symmetrical, then when you were folding in half, it approximately matches. So the shape of this should be symmetrical since mean and the median are almost the same. Okay? So again, this was a good exercise showing that if something is out of scale, like if you're drawing by hand, there is always a mistake, because if you're looking at this, then you would say, oh, this is a little skewed to the left, right? But in reality, that's not the case. Okay, that was that, and let's do. I wanted to do a histogram review. Okay, alright, so let me just copy over these again here. Okay, so we're gonna make a histogram. I'm gonna do two different ways of doing this. So let's just make the intervals first. So the minimum score we had was 53. So we're gonna start from 50, not including 50, okay, comma 60, and including 60, okay, and again 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Okay, these are the intervals, and we're going to count the frequency first, right? So frequency, and then we have relative frequency. Okay, so for frequency, let me just write this down here. Because we're excluding the 50 and including the 60, this looks like what? Okay. Alright, so this looks like this. Greater than 50 and less than or equal to 60. Okay? And if we're using COUNTIF function, right? I'm explaining this again, 50 and 60, say. We're going to count if anything greater than 50, right? Because that's the function that we have. You cannot do a combined inequality in COUNTIF. So we're going to do yes, just give it a moment. Alright, so we're going to do anything greater than 50. Okay? But notice that 50 is not included. Okay? And now we're going to subtract anything greater than 60. Okay? So anything greater than 60 is deleted. So what I'm saying here is that we're only left with numbers greater than 50, right? Up until 60, because we subtracted anything greater than 60. So we actually include 60, right? So that's how we come up with this. So if you were to write the formulas down, okay, so it would be what? COUNTIF range, comma, quotation, greater than 50, and then we're going to subtract COUNTIF this, comma, greater than 60. Okay? So it looks like this. And we're going to lock these values by pressing F4. Okay? What did I do? Oh. Okay, so here I forgot to do a quotation mark. So always be careful with it. And it's saying that there is only one observation in between these intervals. So, and that is 53. Right? So if you drag this down again, go to the right bottom corner, and if you see the plus sign, you can just double click this, and you see that these are all 1. Why? Because the values are not changed. 50 to 60, it's doing the same thing over and over again. So we're just going to change these values to 60 and 70, and that's an easier way of doing this, because you don't want to write the whole equation down, and that would take way too long, right? So just using some tricks. So this is 80 to 9, 80 to 90, and here is 90 to 100. Okay, right? So if you do the total, what is the total? Sum and sum these up, we have 24. But actually we know that the total does not equal 24, and I believe I made a mistake somewhere along here, because the minimum value was 47 instead of 53, so we actually need another interval. So let me just copy and paste. So we need another interval from 40 to 50. Okay, and you would do the same here, just to count if from the range. And then we would do, let's go up, we would do comma greater than 40, quotation, and then minus count if A2 to A26, comma, this should be A2, comma greater than 50. Okay, so everything else stays the same except for another interval that we have. And if you sum these up, it should be the 2 to the 7, 2 to the 7, right? So we have 25. And for relative frequency, it's always the same. We divide the frequency by the total, but we would lock the total value because we want to use the equation automatically, right? So press F4, press enter, and then just right click, the right bottom corner, double click this, and just to make sure, if we sum these up, we have to get 1 because relative frequency always adds up to 1. So that's the case, okay? And if you were to make a histogram out of this, go to insert, and then we would select relative frequency and go to histogram, and let's make it a little smaller. Okay, so here, this is the histogram that we have, and then we can just write exam 1. And for labels, right? For labels, you can just go to select data, and then horizontal, we can edit this, and you have to choose a label range. That will be our intervals. Enter and enter, we get this. Okay, so this is the histogram. But I do want to show you another way of doing this. We briefly mentioned this before, so let's just go ahead and do this. And we already established that the intervals, the increments between the intervals are 10, right? And we have 40 to 50, 50 to 60, right? So we're going to do that right here. So we're going to write 50, 60, and if you select both of these, and then if you drag it down, it's going to, the Excel will recognize a pattern, and it's going to fill out the rest of the series. Okay, let me just clean this up. Okay, right? And this we call bin range. Okay, this is actually referring back to the same thing we had, 40 to 50. Okay, so when we're talking about bin range, we're talking about the right side, right end of the inequality. So when we say 50, that means 40 to 50. So we're talking about the right side. Okay, and if we have this, we can now go to data, and you can use the data analysis tool pack that we installed. So press on that, and you can find histogram. Okay, So if you find a histogram and click OK, it's going to give you an input range. Okay? An input range is where you have all the observations, so all the data. So this, right, A2 to A26, that's the input range because we have all the data there. And bin range, on the other hand, is the ranges that we came up with, the intervals. So we can also choose this. Okay? So these are, until 25. These are the bin ranges. Okay? And if we choose an output range, okay, because we want to see it here, you can choose that as well. Alright, so we want labels and press OK. See, oh, this is, I don't know why it's like this, because let's fix this. 50 is up there. Okay, I don't know why it's doing this. Okay, let's do this again. Go to data analysis, histogram, right? Bin range is correct. Bin range is, oh, I see. Okay, so click that, and we would want to unselect the label, because label meaning if we have a label for this, then if we were selecting this, we would have to include the bin range. Okay, so if we can try that, and output is the same. So if you do that, we'll get the bin range label right here. So again, this is exactly the same as that. So this is anything less than 50, which is again 40 to 50, and then 50 to 60, 60, 70, right? And we can use this to create a histogram. And we can just go to insert and then another histogram. I did something wrong. Okay, delete this. Alright, so you can select this and go to insert histogram, and again this is the same, and we would just change the values here. Okay, you can just do again, go to select data, the horizontal axis will be changed. Okay, so this is the histogram. Alright, so for the rest of the class and for the lecture, if you were listening to this at home, I want you to do another thing. I want you to so far we did exam 1 score and the final score, right? I want you to do exam 3 and final, right? So I'll just highlight this right here. I want you to do exam 3 and final. Do the same thing for this. So draw a scatter plot, find the correlation, run the regression, and comment on it. Right? Everything that we did so far, I want you to do the same thing with exam 3 score and the final score. Okay? And if you're doing this at home, just do this by yourself. And if you're doing this in class, you can work in groups and as well. So if you finish this, you can in class you can discuss it with rest of your classmates. Okay, so for today, that's it for today, and I will get back to you if you have submitted your homework. I will get back to you pretty soon. All right, so I'll see you at the Q&A session.